The SR-20 makes it easy to get a precise markout on a remote transmitter or sonde. And in this segment, we'll show you how to pinpoint a sonde's position quickly and accurately. The sonde will be locating as part of a SeeSnake video pipe inspection system. The sonde is located inside the spring, right behind the camera head, and operates at 512 Hz. We've put the camera into a drain line that tees into another line after about 8 feet. We've pushed the camera just past the tee, which in these conditions should be well within range of the transmitter's signal. We've turned the camera's transmitter on and set the receiver's frequency to 512 Hz sonde mode. The sonde's location is marked with tape, and our technician has positioned himself directly over it, so let's have a look at his display. The items outside the active view area work the same way as they do in line trace mode. The number in the upper left is the signal strength reading. It will be highest when you're directly over the sonde, and will decrease smoothly as you move away. The depth reading also works the same way. It updates continuously as you locate, and will be lowest when you're directly over the sonde. And just as with line tracing, the depth reading is actually indicating distance, not depth. The reading only reflects the sonde's depth when you're directly over it, with the receiver held vertically and the lower antenna resting on the ground. Next, let's take a look inside the active view area. The map uses icons to represent the position of targets underground. There are two types of targets: poles, which occur at each end of the sonde, and the equator, a plane or imaginary line that passes through the center of the sonde and stretches out on both sides of the sonde until it is so weak the receiver can no longer see it. When the sonde is lying flat or horizontal, and the ground above is also flat, the equator will be located halfway between the poles, and if you draw a line between the poles, you'll find the sonde where that line and the equator intersect. The receiver's display uses icons to represent the position of the poles and the equator. We can map these points by targeting their icons on the display. Now that you're familiar with the receiver's interface, let's locate our sonde. We're going to demonstrate a basic technique that can be boiled down to just 3 steps. Localize the sonde, pinpoint its position, and verify your result. We'll localize the sonde by determining its general direction so we can get close to it. Then once we're close to it, we'll further localize its position by finding and marking the poles. To find the transmitter's general direction, we'll extend the receiver and sweep it slowly in an arc. Keep an eye on the signal reading. When it's highest, you'll be facing toward the sonde. We have its general direction, so we'll lower the receiver and start walking. As we approach the sonde, we'll pick up whichever pole we're closest to. We'll move toward it, center it on the crosshair, and place a marker chip on the ground to designate its position. After we get our first pole, we'll see a double line on the display. This line shows us how the transmitter is lying underground, and in most cases also represents the pipe's approximate direction. We know the second pole is on the far side of the transmitter, and we believe that the transmitter is to our left along this line. If we're right, the signal should increase as we move in that direction, which it does. The equator lies between the 2 poles, and we'll pass over it on our way to the second pole. We'll find the second pole and mark its position. At this point, we've localized the sonde to a position that is somewhere between the 2 poles and directly in line with them. To pinpoint the sonde's position, we'll line the receiver up between the poles and head back to the equator. We'll center the equator on the display and mark its position. To verify our result, we'll make sure that the signal drops off when we move the receiver in any direction away from this point, which it does. This last step is very important. Here's why. When a sonde is horizontal, the equator will be centered over the sonde. But when a sonde is tilted, the equator will be offset, often by several feet. Unlike the equator, the signal reading isn't affected by the sonde's tilt, and that's why it's critical that you always verify your locate and mark the SON's position where the signal is highest. In the past few minutes, you've seen how the SR-20 makes short work of locating remote transmitters using the simple three-step process of localize, pinpoint, and verify. Before using the receiver, be sure to read the operator's manual for additional information not covered in this video. On behalf of everyone at Ridgid SeekTech, thank you for buying the SR-20 receiver, and thank you for watching this video.